So, okay. Last thing I did was install the packages for nkululeko, and that took such a long time, so that now it's the next day. I guess it takes about 2 hours or something. Probably should work on that too. I don't think that all these packages are actually needed, but I'm not sure how to prevent them. Well, anyway, so now they were installed. You can check if everything is in order if you just repeat the command pip install nkululeko. And so now it says, yes, everything is already there and it's fine. So to go further, we go back to our hello world how to example. And the last thing we did is pip install nkululeko. We repeat until all error messages are vanished, or fix them, or try to ignore them. Don't know, whatever works best for you. Now you should have two folders in your nkululeko folder, emodb and venv, the virtual environment. We can check. Yeah, still the case. And now download a copy of the file emodb. If you click here, it is a file on GitLab, on GitHub, and you cannot simply download it. There's no download button, but you can copy it. So just click here, copy the raw contents, and then with your favorite editor, mine on Windows would be Code. You can call it whatever you like. I called it expemodb.ini. So this is for experiments for the emotional database initialization file. And so now the editor opens and it is empty because it was not there before. But with like pasting, so Control V, I can paste the contents of, where is it? The contents, this contents here, yeah, from the GitHub page, I can paste it into my editor. And then I do save. So this is actually Visual Studio Code. I really, that's a really great editor for us. Also, in case later you would like to program something that's really helpful. You see, got syntax highlighting and everything. And yeah, okay. So as you see this, I might explain. You can already see here how nkululeko is working without programming. You have to define everything in this text file, because I mean you don't need to program, but you somehow need to say nkululeko what you want it to do, and so that's what you want to do here. This is the name of the experiment, and this will also be the name of the result folder. This will be the path of the result folder. So a single dot means it's in the directory where you call the script. That's where it starts, but you can give it any other name too, any other path too. Then what kind of databases you want to use. In this case, I called it emodb. It's a free form, yeah, you can call it anything you like, but it has to correspond to the fields then. So if this must be the same as this. And then the path to the database is this one. It's the current directory, and then it's called emodb. And then how to split train and test, or train and development set. And we already defined that for this data set. So the tables, the data set itself has tables, and there's one for training and one for testing. And gold standard means that this is the so-called ground truth or gold standard. It's what the actors wanted in this case. So the portrayals of the actors, whether it was happy or sadness or fear, and that was verified by test listeners. So 20 listeners listened to them and said, yes, this sounds like anger or happiness. So it was labeled too. And we only, with emodb, we only used the percentage of the samples that were recognized by at least 60% of the test listeners. Okay, so the target is called emotion in these labels. And the labels of the emotion is anger, boredom, disgust, fear, happiness, neutral, and sadness. This is the basic emotions that are in this database portrait. And now you need some acoustic features. And in this case, we use OpenSmile features, short is OS. And the model, so a type of a classifier, it's XGBoost. That's a random forest-based or tree-based classifier. And what you can use here is written in, as I said in the very beginning, in the ini file, in these options here. If you go here, you see you have these sections: X data, feeds, model, expl, and plot, and they correspond to these sections. I mean, you don't need them all, but like plot is not needed here, and expl is also not present. But you have them here, and if you want to know, for example, what acoustic features are supported by nkululeko, you can go here and you see, okay, possible values is import, MLD, OS, which we currently have, part, spectra, trill features, WAV to VEC, out model, or expo. And there will probably be more in the future. And with respect to classifiers, you can click on model. And here you see what kind of classifiers and regressors are supported. So base, Gaussian mixture models, k-nearest neighbor, tree, SVM, XGBoost is currently as support vector machines. And the same for regression always, and a multi-layer perceptron. CNN is currently not there, actually. So convolutional networks have not been implemented yet. All right, so this is what this is. You don't have to change anything. It's just that it needs to be there. And then you can call nkululeko by typing Python. So Python is still the language that calls nkululeko. -m for module. nkululeko. So the package is called nkululeko. And inside this package is a file also called nkululeko, which interprets this script here, this initialization file, nkululeko. So you type this again, and you have to tell them where this file is. So you type --config, and then the file that you copied, right? This one here, and that's it. Then you send that its way by hitting enter, and so now there's some nkululeko output. It says running this experiment. The version is 0.40.1. It loads the database from this path. It loaded used these tables that you specified. It split the database with this strategy into train and test, and then it got these labels here. Of course, they always must be the same, but that's just for debug checking. If something goes wrong, you can check these output if something is not correct. So ImaDB has only 10 speakers. We used here 4 speakers for testing and 6 for training. Then the shape, this is the samples. There are 304 samples in the training and 231 in the test. And these samples have the emotion and the gender of the speaker and the age, I think, and something else, perhaps the duration or something. Then the features are extracted, acoustic features. So this is something like the mean fundamental frequency, the pitch, or something of the samples gets extracted first for the test, and you see here it's 88 features. Yeah, so this is a number of test samples. Training samples, still 304. But now the column size. So because this is row number and column number. Column number is now 88, and this corresponds to the features. There are 88 features in this OpenSmile set that is used here. Same for the test. Then again, all the features, and so it runs. You can specify several runs if you want, but we only let it run once, which makes sense for XGB, as it would be always the same. And for one epoch, because it's not a neural net, it only needs to be run once. And the result is 0.52 unweighted average recall. It plots a confusion matrix to this file here. And again, some debug output and the results per class in F1 score. So see each of the classes apart from happiness. I guess I'm not sure if that is the right order here, the same order, because I guess usually worst recognition is for disgust. Well, let's see. We can look at this, the output. If you now do what is in the directory, you will find that now we have 2 more entries. We have the initialization file, and we have a folder called xpemodb. And this folder is the results of nkululeko working. And we can inspect it in the Explorer. So okay, I think I already had one open. Where are we? That's the wrong one. I think this one. No, it's all Zoom. Anyway, I will look for my nkululeko work folder. I'm so bad with Linux. So it's where's C? Here's C users fxpur and then nkulo work. This one. And so this folder xpemodb, this is a result of my nkululeko run. And there are 4 folders in there. Images, models, results, and store. Store is to reuse stuff. So this is the extracted features and stuff that nkululeko works. Because now, if I rerun nkululeko, it will be much faster. It will simply reuse lots of stuff. So whoops, done. Yeah, it says here now reusing previously stored files and also reusing extracted smart features. That's what the store folder is for. The results is also what you already have. So the result is mean for 0.42 unweighted average recall, and this is the results per run. So if you would have several runs, all these results were here, and you would have the mean of all the runs. And then for each run, you have some output here per emotion, exactly precision and recall values. But what's faster to see is so what else is there? Models stores the model. There's nothing in it. Oh yeah, because I didn't say save model. If you say save model, the model would be here. And images, this is the one that I was looking for. This is the confusion matrix. I think I said that in the beginning. So you see the intended emotion in the rows and the predicted emotion in the columns. And you see that all the anger samples were recognized. Bottom looks quite okay. And as I said, disgust was not really recognized so much, but often confused with anger. And really, no, happiness was not recognized at all, but always confused with anger. So might be that the order is actually correct here. So happiness has a very low F1 score. F1 is a combination of recall and precision. And disgust also should have a low score. This it's this one. 1, 2, 3, 1, 2, 3. Yeah, it's rather low. Yeah, so that fits. Okay. And that's for this part. I might show in a later video what else. So the kind of experiments that I can do that right now. The kind of experiments that you could do now is actually experiments by switching here. For example, if you say support vector machine, apart from XGB, you type SVM here, and then you rerun your script. Yeah, if I just do arrow up, then I see the next. And now you get a different result, right? It's the result is lower. It's 0.429 on weighted average recall, and it's done with a support vector machine out of the box. And if I go here, now I have two confusion matrices, one for XGBoost and one for support vector machine. And I can compare them and see, okay, this one worked less good. And that does not mean that XGBoost must be better than support vector machine in all cases, but you have lots of hyper parameters that you can tune now. You would have to tune the support vector machine, for example, by giving it a different C value, something. Okay, so that was that about nkululeko, and thanks for watching. And I hope you have fun with nkululeko. Bye-bye.